Okay, so this is the video for the 4-2 practice Form K. So what's a little weird about number 1 is it doesn't have anything for the given part. And so I'm basically going to have you write given the figure, which is over here. Given the figure. Okay, so what you're given is that Rx is congruent to Sx, and that's what's here because of how it's marked. And Qx is equal to Tx because of how it's marked. So that reason, that little question mark, is going to be for given. As a reminder, this is called a flow proof. Now this part, it's not really that dark, so I'm just going to darken it. It's those angles. And so you've got QXR, so that's this angle, and TXS. TXS is this angle. So those are your vertical angles. So we put vertical angles are congruent. Vertical angles are congruent. And just as a quick reminder from what I did on 4-1 about what letters correspond, usually, but not always, it's the ones on the same line that correspond to each other. Like since this has 1 mark and that one has 1 mark, then R corresponds to S, and Q corresponds to T. You could do triangles, you could do rectangles or whatever, and then X corresponds to itself. So just remember there's that technique if you want to use it. The next part says with those 2 inputs, what's your result, and it's basically the proof statement. So it's triangle QXR congruent to triangle TXS. And that reason was side angle side because the angle is between the 2 sides. Side angle side. Any questions? Okay. The next one says, what other information, if any, do you need to prove the 2 triangles congruent by side angle side? To start, list the pairs of congruent corresponding sides or parts that you already know, and then after that, what other information do you need? So A to B, that's a 1 mark thing, and that have to be H to G. So I'm going to put H, G, and put a bar over it like we had the bar over it for that. Remember, the bar means it's a line segment. It has a definite stopping point. And then the other one, you got BC, so then it's going to be GF. So that's the information you already know. The extra information would have to be, we want side angle side, it's got to be this angle and this angle. So those 2 correspond. So over here we're going to put angle B equal angle G. So that's the additional information we need. Any questions? Okay, then for this part, with 1 mark we have XZ, and again with 1 mark we have RT. So that's how that works. And with 2 marks we have ST, and with 2 marks we have YZ. And then we also know about the angles, angled Y and angle S. Okay, so you have your first side to your first side, your second side to your second side, and your angle to your angle. Is that the right angle for the side angle side? No, it's not. It's not the right angle, or not the correct angle for side angle side. So what we actually need is Z, because it's in the middle, and T. So we need angle Z equal angle T. So I'll put need over here too. Any questions? Okay, the next one says, would you use SSS or SAS, or is it not enough information? And so here we'd have 1 mark for these and 2 marks for these. Then the third side is the reflexive side, so we do have enough information. It's going to be side, side, side because of the third side reflexive. Third side reflexive. Okay, and then for this one, we've got a side there which corresponds to that one for a change, and this one to this one. We don't have a third side already listed, and we do have vertical angles automatically. So this would be your side angle side, and because of the vertical angles. There's one other part that I want to put for this one, because like I've said before, in most cases it's like this one, where the ones that are on the same line relate to each other, like the Q and the T and the R and the S. But on ours over here, it's not that way. And so I want to put some letters to show you. So if this is X and this is Y and this is Z and this is A down here and B up here, we'd say normally X corresponds to the A. I'm just doing X with an arrow and an A. But here, X corresponds to the B. You'll see the difference? It's because XZ is congruent to BZ. Since XZ equals BZ. So that's why X and B have to go together instead of X and A. Any questions about that? Okay. Now they're having you work on the distance formula. So our normal distance formula would be D equal the square root x2 minus x1 squared plus y2 minus y1 squared. And that's what we're going to use for these four. But on the ones they did something weird. They did D equal the square root, and they did y1 minus y2 squared plus x1 minus x2 squared. These are really equivalent. They just put the y's first instead of last. So we're going to go with that. They are indicating, like for FG, this would be x1, y1, and x2, y2. And so they're doing 0 minus 4 squared, and then 0 minus 0 squared. So that ends up being the square root of 16 plus 0. Because when you go negative 4 times negative 4, it's positive 16, and so you end up with a length of 4. So 4 is what goes in the box. And on this one, they did 4 minus 4 squared, which would be 0. And now this part is a bit weird, so let's just type it. Since I'm doing this in steps, I'm going to say 1 minus parentheses negative 3, enter, and then squared 16. So we end up with the same thing. We get plus 16, so the square root of 16 is 4. So that's if you break it up into steps. If you'd rather just write the whole thing out or type the whole thing out, you can. It's 4 minus 4 squared. Now notice when I did that and I opened my parentheses, it automatically closed it, and then I had to move to the right in order to put the squared. And then on this one, plus parentheses, and so it opened that parentheses. Now my cursor's in the middle, and I go 1 minus another set of parentheses, negative 3. Then it's closing it twice, so I just went to the right twice, and then I put squared, and I get 4. So be very careful as you're typing this, but you should get the same answer for those two. Any questions? So this is your distance formula, which you used in algebra. Now for GH, and so basically we know these sides are congruent because they're both 4s. Now for GH, that's what we're going to do now. And so we use the 0-4 ordered pair and the 3-0 ordered pair. So if we use our formula, it's going to be 3 minus 0 squared, because you go this 3 minus that 0 and square it, plus 0 minus 4 squared. So that's the right minus the left. Okay. So 3 squared is 9, and negative 4 squared would be positive 16, not negative. So remember, this is like if you use parentheses like you're supposed to, negative 4 squared is positive 16. Some people might have accidentally typed it this way, which is wrong. You have to use parentheses when you're squaring a negative. So if we have the square root of 9 plus 16, that's the square root of 25, which is 5. So 5 is our answer. Okay, then for KL, this is going to be the square root 1 minus a negative 3 squared. Okay, KL, so we've got this. We're doing this 1 minus a negative 3, which changes it to plus 3, and we square it. And then we do the 1 minus 4. So plus 1 minus 4 squared. This gives you the square root of 16 plus 9, which again makes 5. So both of those are 5. Now we do HF. So for HF, we get 3 minus 0 squared and 0 minus 0 squared, which basically just simplifies to 3. HF, we did this 3 minus that 0 and this 0 minus that 0. Okay, so you end up with a square root of 9, which is really 3. And then for the LJ, we get the square root 1 minus 1 squared plus 1 minus 4 squared. So LJ, we're doing 1 minus 1, 0, and square it, we get 0. And then 1 minus a negative 4 is negative 3, and you square that, you get positive 9. Then you need your square root, which is 3. So these are based on the 3, 4, 5 right triangle. Any questions? Okay, since we did so many of those, I'm going to skip number 7. And then let's go on to number 8. Oh, so by the way, because this set corresponded and that set and this set, then we'd say triangle FGH is congruent to triangle JKL from side, side, side after doing the distance formula, because now we know all 3 sets of sides are equal. So we didn't have to do anything related to angles. Okay, so now for number 8, can you prove them congruent? And if so, write your congruent statement and the postulate. So we've got a side, an angle, and a side. And it's 1 here and then 2. This one's also side, angle, side, but it has it reversed. So think of this one as reflecting, because the Q has to relate to the Y. And the S has to relate to the W, because on that case both of those have 2 marks. So we do have side, angle, side, and our triangle congruence statement is QRS congruent to Q relates to the Y, so it's YXW. I left off the triangle symbol, but that's alright. Guess I can sneak it in there. Okay, any questions on 8? Okay, number 9, we've got 4 of the sides equal, but we don't know anything about this other set of sides or angles. So this one is not enough information. We would either need FH equal to KH for side, 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 or since we need these angles, it'd be angle G equal angle J for side, angle, side. Not enough information. We either need the bottom sides equal for side, 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 or we need G equal to J because of side, angle, side. You couldn't use angle F because it'd be SSA. We want SAS. Any questions? Okay, we're going to skip number 10. There's not enough room to write it out, and we will do 11 though. Okay, this one says BD is the perpendicular bisector. What that means is BD cuts this into half, so this is equal to that. And that's what's marked. Now they call it segment bisector here, but they should have put perpendicular bisector, but I'm just going to leave it alone. And we do know that perpendicular means it's a right angle. So the next step, like we did on the other one, after you have that they're right angles, we know all right angles are equal. So we're going to put angle ADB equal angle CDB, because all right angles are congruent. Or you could put equal, so that means the same thing. So it's not like one right angle would be 90.5 instead of 90. It's just 90. Okay. So now we actually have a set of equal angles. And now the third side we need is this one. Again, we're doing side angle side. So it's this side, dB equal to dB. And that's reflexive. So if it's in both the triangle above and below, it'd be reflexive. And then we put our proof statement here, which is the triangle BAD congruent to triangle BCD, and in this case SAS, side angle side. Okay, that's the end of the practice form K.